So in this lecture, we will discuss how to estimate ARIMA model. So to estimate ARIMA, we mostly follow 4 steps. In the first step, we identify the model, and in the second step, we estimate the identified model, and in the third step, we diagnose the estimated model, whether the estimated model is best to forecast for the future. In the fourth step, we use the ARIMA for our prediction purpose. In the identification process, we first select D. As we remember, ARIMA has 3 components. One is AR, second one is integrated or difference component, and third one is moving component. So at first we select D. So D is the number of difference to make the series non-stationary. For example, if Y is non-stationary, if we take the first difference to make Y as stationary, then D equals 1. If Y is already stationary, that means we are not making any difference to make it stationary. Then D equals 0. So this is how we select D. In the second identification approach, where we need to select the appropriate order for P and Q. Some people choose P and Q using autocorrelation function and partial autocorrelation function. There are other approach of choosing P and Q following the Akaike information or Bayesian information criteria. So what we do basically here, we estimate the ARIMA model, and each ARIMA model has some information criteria like AIC or BIC. So we choose the model where AIC has the minimum values. So we choose the model where AIC has the minimum value or where BIC has the minimum value. So this is how we select D, P, and Q. So the model is identified. Once the model is identified, then we go for estimation step. We just simply estimate the model and check whether the coefficient are statistically significant or not. So once the model is estimated, then we go for diagnostic checking. So in the diagnostic checking, what we basically check, we check whether the model is fit for prediction. So how do we check it? Some people use autocorrelation function to check it, or some people statistically check whether the residual from the estimated ARIMA is white noise. So in this case, null hypothesis is whether the residual is white noise. Once the residual is white noise, then we can say the model is best for prediction. In other words, the null hypothesis is whether the residual is white noise. So when we accept the null hypothesis, that is the residual is white noise, only then we can say the model is fit for the prediction. If the null hypothesis is rejected, then we can say the residual is not white noise, that is the model is not fit for the prediction. So once the model is not fit for the prediction, we repeat the same process from the beginning and find the best model for the prediction. So this is how we can choose the best model for forecasting. So once the best model is chosen, only then we can use the best model for the prediction purpose. In summary, to estimate an ARIMA, we first identify a model, then we estimate the identified model, and then we check diagnosis. Once the residual from the estimated ARIMA model is white noise, then we would say the model is suitable for forecasting. Then we can use the model for the forecasting purpose. Once we find the residual is not white noise, then we go back to the identification steps and repeat the same. This is how we iteratively do the same process and find the best model for the prediction purpose. So in the next section, we will discuss how to use ARIMA in Stata, as well as how to forecast a time series variable using ARIMA model. Thank you.